Hello everyone, I am Sindhu KB. In this video, we shall discuss about volumetric analysis. First, we know the definition of analysis. Analysis is a process of separating, identifying, and quantifying a matter. Chemical analysis means the process of determining the physical property or chemical composition of a sample. In chemical analysis, there are two types: qualitative analysis and quantitative analysis. Qualitative analysis means identify the chemical species present in a sample. For example, in the sample, there are so many constituents present. For example, calcium, magnesium, zinc, etc. First, next, quantitative analysis. Quantitative analysis means measure the amount of chemical species present in a sample. Means the chemical species present in a sample means qualitative analysis. How much chemical species present we determine is known as quantitative analysis. In volumetric analysis is a type of quantitative analysis. Volumetric analysis can be defined as amount of substance. It is determined by measuring the volume that it occupies. Is known as volumetric analysis. Volumetric analysis is also known as titrometric analysis. In titrometric analysis, we know the concept. We determine the concentration of desired constituent present in a sample. The apparatus can be used in titrometric analysis are burette, conical flask, pipette, and standard flask. The apparatus can be used in volumetric analysis, and this first one is burette. Burette is a long graduated glass tube marked with a measurements. Burette can be used to measure the known sample and transfer to the conical flask. The second one is a conical flask. Conical flask can be used to mixing the titrant and titrate and also heating purposes. And standard flask. Standard flask can be used to prepare the standard solution of a known volume with a known concentration. And pipette. Pipette can be used to transfer the small quantities of liquid to the conical flask. The terms used in volumetric analysis are titrate, titrant, titration, endpoint, equivalence point, indicators, titration error, and standard solution, etc. The terms used in volumetric analysis in this first one is titrate. The substance being titrated is known as a titrate. It can be taken in a conical flask to determine the unknown concentration of a sample. And the second one is titrant. The solution of known concentration, it can be stored in a burette. It can be added to the conical flask to determine the unknown concentration of a sample. The third one is titration. It is a quantitative chemical analysis. In this process, we determine the concentration of identified analyte. Endpoint can be defined as the point at which the reaction between the titrant and titrate is just complete. It can be indicated by the change in the color of indicator. Is known as endpoint. Next is equivalence point. Equivalence point is also known as a theoretical point, where the moles of titrant added exactly neutralize the moles of analyte present in a sample. Next is an indicator. Indicator is a chemical substances. It can be define the completion of a reaction by during a titration by changing color. In indicators, there are three types: internal indicator, external indicator, and self indicator. In internal indicator, the indicator can be added into the conical flask. Is known as internal indicator. For example, phenolphthalein, methyl orange, etc. External indicator means the indicator can be added outside the conical flask. Is known as external indicator. Next, third one is a self indicator. In titration process, we take two solutions. One is known concentration solution. Another one is unknown concentration solution. Um, in these two solutions, one of the solution can be act as an indicator, is known as a self indicator. Titration error. Titration error is also defined as a small difference between the experimental endpoint and actual endpoint. Actual endpoint is known as a theoretical endpoint. The difference between the experimental endpoint and actual endpoint is known as a titration error. For example, the experimental endpoint is 5.8 ml by doing the titration, and the actual endpoint is 5 ml. 5.8 minus 5 is equal to zero point 0.8 ml. Therefore, zero point 0.8 ml is the titration error. Next is a standard solution. The solution of accurately known concentration is known as a standard solution. In this, standard solutions uh, can be classified into two types: primary standard solution and secondary standard solution. The substance can be directly weighed to prepare the solution is known as a primary standard solution. Therefore, there's in primary standard solution, the concentration of the solutions cannot be vary with time. And the second one is secondary standard solution. In this secondary standard solution, the concentration of the solutions can be vary with respect to time, because in secondary standard solutions we used in the analysis, before the analysis we do the standardization with primary standard solution. The next topic is classification of volumetric analysis: acid base titration and redox titration, complexometric titration, and precipitation titration. In this first one is acid base titration. It involves the acid base neutralization reaction in the presence of water as a solvent. The combination of hydrogen and hydroxide ion to form a water. For example, the HCl reacts with sodium hydroxide to form a sodium chloride and water as a product. The sodium hydroxide can be taken in a burette, and hydrochloric acid can be taken in a conical flask. When we add a drop by drop of sodium hydroxide to the conical flask containing a hydrochloric acid, it forms a sodium chloride and water as a product. It is known as a neutralization reaction. The base present in a burette, it will neutralize the acid present in a conical flask. It is known as acid base titration. Redox titration. Redox titration means in this titration we have used the two solutions. The one solution will act as an oxidizing agent, the another solution will act as a reducing agent. This titration involves the reaction occurring due to the transfer of electrons among reacting solutions, are either oxidizing agents or reducing agent. For example, oxidizing agent is KMnO4 and reducing agent is sodium thiosulfate. The example for the redox titration is KMnO4 versus oxalic acid. Complexometric titration. In this type of titration, the titrate combines with the titrant to form a complex salt. The complex salt may or may not be soluble in water. The example for the complexometric titration are: copper sulfate reacts with 4 molecules of ammonium hydroxide. It gives rise to tetramine copper 2 sulfate as a complex plus 4 molecules of water. The another example for the complexometric titration is: silver nitrate reacts with 2 molecules of potassium cyanate. It gives rise to potassium dicyanide 1 plus potassium nitrate. Precipitation titration. In this kind of titration, the cation combines with the anion to form an insoluble residue, and also known as a compound with very low solubility, is known as a precipitation titration. The example for the precipitation titration is: silver nitrate reacts with sodium chloride. It gives rise to silver chloride plus sodium nitrate. Silver chloride is a white precipitate, can be formed in the precipitation titration. The barium chloride reacts with hydrosulfuric acid. It gives barium sulfate as a precipitate plus 2 molecules of HCl.